Well, hello everyone, and welcome to another video from the Canal Sidings Model Railway channel. And this video will be part 2 of my automatic signalling system that I am developing. If you haven't watched part 1, then I suggest you do that first, because I'm going to refer to things which I did mention in part 1, and I may not mention them again now. So I'll put a link to part 1 at the end of this video, so if you want to look at that first, then skip to the end and you'll find it, and then you'll be able to go and do that first. Okay, I now have it completely disconnected from my computer. I have rebuilt the whole breadboard, so I now have 2 Arduinos, one here and one here, both programmed with the same code, and each one capable of driving 2 signals, with an optional sequencer on either or both of those 2 signals. The sequencer simulates a train passing signals that are past that signal that are not actually included or modelled. You'll also notice from the first video I now have 5 signals up here instead of 3, and 4 of them are in use. This one is the 5th one I got in the pack. I just thought I'd show you the 5 signals. What you can see is that they do vary a bit in height, so you can see that they're definitely handmade in China, and they work very well. I don't have any problems with them at all. The other thing that I've done is I've added 2 switches above what we had before. These are the switches that simulate the sensors on the signals, and these 2 switches are to allow me to force a signal to go to red at any time. So if I hit that button, I have forced that signal to change to red, and of course the signal in front of it has gone to yellow. Now that could have been because there is a point here that has been set against the trains passing it, in which case we can use an output from that point to say I am in this position, to take the place of that switch and set the signal to red. As soon as the point goes back, the signal goes back to green, and the one behind it goes back to green as well. And I can do the same with this signal, which is the next one in the chain, and as soon as I let go, the signal goes back to green and the one behind it goes back to green. So that's just an extra that I've built in, which wasn't in the last test. The 4 signals are in order, so we're passing them in this direction, and 2 of them are in there and 2 of them are in there. I think this one and this one are in that Arduino, this one and this one are in that Arduino, but any order is possible. It depends just how you wire the Arduinos together, as to which signal is in which order, really. And you could even use that Arduino to control one signal on this track and one signal on a parallel track, which are not even related to one another. So that's where I am at the moment. I have no PC connected this time. These 2 wires here, this red and the black one, are now powering it from my bench power supply, which is set to 5 volts. And what I can do is now demonstrate the whole system again, this time with 4 signals instead of the 3 I had before. So what we saw last time was a train enters from this side and passes its sensor, and that signal goes red. It then moves on to the signal, the sensor that's past this signal. That signal goes red, turning the next signal yellow. And then we move on to the next signal sensor. We pass that signal, it goes red, the next one goes back to yellow, and the previous one goes back to green. And then we can move on to the last signal, pass its sensor. Now remember, this one has got the sequencer on it, so it will automatically sequence through yellow and then back to red, sorry, back to green. And the other signals will follow as expected, back to yellow. And the delays on this are adjustable in the code. So now we have a completely clear set of signals having passed a train through. And that you saw last time, and there's no real difference in that. It just functions the way it did before. But these two switches now can allow the signals to be set to red. And they can come from anything. They don't have to be switches. They can come from sensors, whatever you've got. So long as they can pull low, then they can set the signal to red. So if I set that signal to red, simulating that somewhere in front of this signal there is a point set against the trains, this signal doesn't have to go to red because it's not, the track behind it is clear. So we have this signal red now, and as soon as I remove that clamping signal, that go to red, it goes back to green, and the signal in front of it goes back to green. All pretty straightforward stuff. No trains involved in that at all. But what happens if we force that signal to red, and now a train enters from here? Goes through that signal, sets it to green, goes past the next signal, which is the one that's yellow at the moment, can pass the yellow signal, sets that to red, and arrives at this signal. But of course it can't pass it. So we cannot press this button, wrong one, to allow the train to pass this signal. To say the train has passed this signal, I should say, simply because the signal has said to the train, you cannot go any further. So we now have a train standing at this signal, and this signal red to protect that train from another train arriving here. So the next thing that's got to happen is that we have to take the forcing signal, the forcing red, off of this signal, which would be whatever the line obstruction is cleared. So I do that. Now that signal goes to green. The train standing at this signal can now move, but until it does, that signal must stay at red. So we'll move the train that's standing at this signal. And now, oh, sorry about that, there's a bad connection, that's why that flashed. One of the breadboard connections isn't very good. So now we have changed this signal to red because the train has passed, and then we can move on to this signal, and the signals have now gone back to their normal operation, and that one is now sequencing through to the all green condition. So that's an extra that I've added since last time. What I've also been looking at are sensors for the signals, and I've decided upon this little beast. I don't know how well I'm showing that. I'll put it there. This consists of 3 connections here, a little circuit board and a photodiode and a phototransistor, and here is an adjuster to set its sensitivity. It runs off of 5 volts and it pulls low when it detects something. So this one is VCC, this one is ground, and this one is the output. So if I actually put it onto my breadboard, if I can put it in the right place, which is there. Right, I hope you can see that. I have just added that to my breadboard now, and it's powered. As you can see, the power light is on. And if I put a train over it, the sensor comes on. If I take the train away, it goes off. And if I now put this sensor where this signal is, this one, take that off of there, so this no longer sets that signal, and put it into the breadboard here, now when I operate this, the signal goes red, and of course it will sequence back again. Go back to green, and I can pass it with a train, and when the train has passed, you see that that signal, that light down there, indicates that we passed it. So what we now have is a sensor instead of a switch. And all we've provided it with is 5 volts from the from these two wires, and this one was the one that went to that switch that normally operated that signal. So if I go there, try and operate that, I can't. If I go here, I can. So they are the modifications I've made to this board. The sensors, I got that one from a supplier in the UK, and it cost me £2.50. I have since found those sensors from Chinese sources, and I have just ordered 20 of them from an Amazon supplier. Now bear in mind, £2.50 I paid for that one via Amazon from China to be delivered early November. I have ordered 20 for the sum total of £5.67. That's only just more than 2 of these cost. That's about 27 pence each. So they're not expensive. And even if you have 1 or 2 failures in the 20, it's not going to be that bad. I don't expect any failures because it's a very simple circuit. It would be very difficult for it to go wrong unless you trod on it or something and broke some wire. And the idea is that you make these sit so that they come up between the sleepers. And when the train passes, that's all right, it's already red. Yeah, when the train passes in this direction, so I'm upsetting the signal now. When the train passes in that direction, it will trip the sensor. And I've organised the system such that another modification I've made since the last iteration is that I've modified it such that all the time the train is passing the sensor, the sequencer doesn't start. And I've also made it so that there's a little delay between the sensors being non-obstructed and the sensor actually going off. So effectively what we've got is while the train is passing the sensor, that signal will stay red. When I let it go, about 2 seconds later it'll go yellow, and about 7 seconds after that it'll go red. They're just arbitrary times I've put in because it means that I know which time is which and they're far enough apart. The delays, and there are 4 of them of course per Arduino, because there are 2 signals, each one with its own independent sequencer, and there are 2 delays, one for how long it stays yellow, one for how long it stays yellow. Sorry, let me get this right. One for how long it takes to go from red to yellow, and one for how long it takes then to go from yellow to green. So 2 times. And at the moment, those 2 times, 4 times altogether in one Arduino, 2 for each signal, are hard-coded. Well, they're hash-defined at the beginning of the code, so they're very easy to change. You don't have to find them in the code. You make one change for each delay, and that'll work throughout the code. What I'd like to do is come up with a way of being able to set them with pots like this, with adjustable pots, potentiometers, so that you can actually twiddle the pot and be able to see the time on the signal change. But my biggest problem here is lack of pins on the Arduinos. I don't want to go for a bigger, well, the next Arduino up is the Mega, and they're expensive, and we really don't want to use a Mega on this. You'd have to put a lot more signals on it to make it cost effective. So we may be stuck with having to change the delays hardwired in the code. I really would like it to be able to come up with a way of being able to use pots to do it. And what I would like to be able to do is come up with a set of pins that you can bring out to a board, because you're going to have to mount these on some kind of board anyway, these Arduinos. And a way of bringing out a few pins to a header on that board that you can plug a remote time adjuster into. Yeah, and you can close a switch on it, which will say I want to set the timing for signal 1 or signal 2. Yeah, and then adjuster pots, 4 of them, for the timings on signal 1 and signal 2. And then once you've done that, when you turn the times off, it realizes, sorry, when you turn the adjuster switches back to normal again, the system then saves those into the onboard EEPROM. And then every time it loads, it reads the values that are stored in the onboard EEPROM. So that's another way of doing it, but it's going to take at least 4 I/O pins to do it. Yeah, it's going to take several I/O. I really haven't worked out how to do it yet, as you can see. I'm still trying to come up with the best method. But it would be nice to be able to just plug something in under the baseboard into each one of those signals and adjust the delays, so that when you think the delay on that could do with being a bit longer, so you can just plug in and you know which delay it is. It's the red delay and the yellow delay. That's red to yellow and yellow to green. The RY delay and the YG delay. And there'll be an RY and a YG for each one. I'm thinking out loud here, and it's something that's completely possible to do in software, but have I got the hardware resources to do it is another matter. So that's where I've got so far with all of this. Now, what I have done is I have made a package of files, 4 of them altogether, one of which is the Arduino code, one of which is a text file with quite a bit of information in it, and the other 2 are these PDFs. Now, I don't know how much of that PDF you can see. Okay, not all of it. Okay, let me just hang around the back there. Now, what this PDF shows, I'm just going to look see if you can see it. Oh dear, I can't see that. I'm really struggling to see the camera here. Oh, you can't see it. Oh, sorry, now I've knocked the camera. I've not got my remote viewfinder set up. But this is one of the files, which is a PDF. Sorry about the printing, my printer is messing me about. But this basically shows you the 2 signals, signal 1 and signal 2, that are in each Arduino, and tells you the Arduino I/O pin that the signals are connected to, and then a brief explanation of what each signal is, what each pin does on the Arduino. And then there is an example of connecting it up. The bottom, which I'll bring it up, it shows 4 signals, just like I've got on the test rig, and it shows 4 sensors. It shows the signals and where they appear on the track. That's all this line at the bottom shows, where the signal should be on the track with respect to the sensor. And these are repeats of these, so that you can see how they're wired together. And this is the common on the signal that's wired via a 1K up to VCC. So that's just a quick explanation of that for anybody who downloads the package. And the other file is this one, which contains examples of how we might do junctions. And the same rules apply. That just shows you where the signal sits on the track. These are points. That is an output from a point that you can see put back to the force red. And this one, this other page, if I can get it to come across far enough and get my thumbs out of the way. This one is a junction which is a trailing. This one's a facing junction, this is a trailing junction, where there are two signals coming in, and I have actually failed. Oh yes, both of these signals, one will be here and one will be here. Yeah, and the sensor is down here, but the signals will be sitting here. They are, one's there and one is here. It's really hard for me to hold this like this round the camera, so I'm going to put it down. But those two files are also included in the package. Now, down at the bottom of the video, in the narrative at the bottom of the video, that's in your case down there under the video, there will be a link to my Amazon Drive, and that link will take you to the 4 files. To download the files, you simply highlight the file, don't click on the file, click next to the file in the blank space on the right, and you can highlight all of them or one at a time, it's up to you. And once you've highlighted the file or files that you want, just go up to the top right, up towards the top right corner of the screen or the window, and you will see a download button. Press that download button or click on it, and you will be able to download the files in the normal way and save them wherever you like on your PC. For anybody who showed an interest in the first one as, oh, will the files be available? Well, there they are. They're beta. It's the beta release of the software for the Arduinos, for the 2 signals per Arduino. The version number at the moment is 1.3 beta, which demonstrates that I haven't necessarily finished, but I've done quite a bit of what I wanted to try. Essentially, what it appears is that these signals can do exactly what any signal connected together with Heathcote Electronics boards can do. I haven't copied Heathcote's systems in any way, but having worked out what I needed and what was required, I then went and had a look at Heathcote's system, and I have come up with pretty much the same inputs and outputs as Heathcote have got. It's just that my sequencers are built in to the Arduinos, whereas if you want a sequencer on the Heathcote system, you buy one of their MAS sequencers for each signal. It does make Heathcote's system quite expensive. That is not a slur on Heathcote. It's a damn good system. It works, and if you can afford it, it's probably worth buying. But I want to do it my way. This is totally non-commercial. It can't be. You couldn't commercialise this if you were using an Arduino to do it, simply because you can't protect the Arduino, not that I know of, against reverse engineering the code and building your own and sending them out as if you did them yourself. So anyway, there you go. Any contact with me that you want, if you have any problems with downloading, you have any problems understanding anything, or you have any problems using anything, or if you find any bugs, just let me know. I have included in the text file, that is the 4th file that you get, my Gmail address. So you can contact me directly if you download the files and come up with any a wish list or anything. I can't say that whatever you wish for I can do, but I will consider everything and see. You need to tell me why you want it, or not why you want it, but where you think it's useful. But you know, let's try and share this around. Let's try and produce something that everybody can use if they want to. And I can always just leave the whole thing up on my Amazon Drive. Once we get the final version, it can all sit on my Amazon Drive, and anybody can download it and use it. So do as you will. and I hope that you like what I've done. So that's it. Don't forget, video number 1, if you didn't see it, will be on the screen very soon now. Please subscribe, like or dislike if you must. Leave a comment, and certainly try the code out if you can. Let me know what you think. Bye for now.